This is the notes for section 8.2, fundamental properties of area. If you haven't done so already, make sure you stop the video at this time and read the section before going on with the notes. We'd like to first define what area is, something that you've worked with quite a bit through other courses. When we say area, it's the measure of the space covered by a two-dimensional region. Okay, the key is that we're talking about a space that's being covered. Usually, or when we measure space, we're going to measure that in square units. So as I look at this picture here, the area, which is 135 square units, is represented by the stuff that is inside of this rectangle. As I move the rectangle around, it's going to change the area. It changes the perimeter as well, but it's going to change the area more substantially. Okay, you'll see that the area inside still represents the number of square units that we have there. So the four fundamental properties of area and the area postulate. From your reading, you should have filled out this section of your notes, including all of the missing information there. But I'd like to just take a minute to talk about each one of these different properties and just summarize them a little bit. The first is the uniqueness property. What the uniqueness property tells us is that if you have a polygon and you have a region of that polygon, the area of that polygon is unique, meaning that there is only one area for any given polygon. The congruence property just says that if you have figures that are congruent to each other, well, then their areas must be the same as well. The third property, the additive property, it says the area of the union of two non-overlapping regions is the sum of the areas of the regions. What the additive property does is it allows us to take a figure and break it into other figures that we can find the area of. As long as we've covered the entire figure, we can add those areas together to get the area of the entire figure. And we'll really be applying that today in some of our problems. Okay. The fourth and final postulate, or area postulate property, is the rectangular formula. Every formula that we're going to have for area is really built off of the idea of the rectangle formula. And that just says that the area of a rectangle with dimensions of length and width is the length times the width. Therefore, area is equal to length times width. So everything that we do with area formulas will be built off of that most basic formula. So I'd like to take a look at a couple of problems now that relate to the area postulate. And the first is, if you're given a figure that is not a rectangle, we can still find the area of it by using the fact that we can break it up into smaller rectangles and add the sum of those to get the total. So it says find the area of the region by breaking it up into smaller polygonal regions. So as we look at this, there are a number of ways that we can break it up. What I'd like you to do right now is see if you can pause the video and take your picture and see if you can break it up into rectangles. Okay, so as I look at this, I've divided my rectangle up. Now, this is certainly not the only way that you have to do it, but I've divided my rectangle, or my figure, into all rectangles, and now I need to find the area of each of those rectangles. To do that, I have to look at the ordered pairs to find the length and width of each of those rectangles. So as I look at this first rectangle, I'm going to call this rectangle 1 right here. I'm going to find the area of it by finding its length and its width. Well, if you're trying to find a distance that goes horizontally, what you're going to be doing is you're going to be looking at the difference between the x values. And if you're trying to find a distance vertically, well, then you have to take a look at the difference between the y values. So in this particular first rectangle, the distance from J to I, that length is 2 units because the difference between 3 and 1 is 2. And then if I look at this distance going from I all the way up to H, that will give me the length of that rectangle. So I'm going from 1 to 6. Well, the difference between that is 5. Therefore, the area of rectangle 1 is 5 times 2, or 10 square units. Okay? So for each one of those rectangles, I'm going to do the exact same approach. I'm going to find the dimensions, and then I'm going to multiply them together to get the area. So if I look at rectangle 2 here, if I look at vertically, I'm going from 8 to 6, so that would be 2 units. And horizontally, the furthest left I'm at is at 1, and the furthest right I go to is 6. So the difference between 1 and 6, that gives me 5 units as well. So that rectangle actually has the exact same area of 10 square units. Okay? Now let's take a look at rectangle 3 and find its area. So if I look at the width of rectangle 3 going from 6 to 8, that would be 2 units. And then I'm going from 3, if I'm looking at it vertically now, I'm going from 3 up to 8. Okay, that is also 5 units, therefore that is 10 square units. And then finally rectangle 4, I'm going from 8 to 10, so this is 2 units. And I'm going from 5 to 8, so this is 3 units. So the area of rectangle 4 is 2 by 3, or 6 square units. And then to find the area of the whole thing, I can add those up, which would be 36 square units. So let's take a look at example 2 here. It says a family is installing ceramic tiles on a kitchen countertop. The countertop is 16 feet long and 2.5 feet deep. There are 4 parts that will not be tiled. A 3 foot by 2 foot sink opening, 2 openings that are 2 feet by 1.5 feet for cutting boards, and an opening that's 1 foot by 2 foot for knives. Each tile is 1 foot by 1 foot and costs $2.20. How much do the tiles cost? So what I want to do first of all is I want to just draw a picture of what's going on. So I did my sink cutout here that's 2 by 3 in terms of feet. I have the cutting boards that are 2 feet by 1.5 feet each. Okay, and then I have finally the knife cutout, which is 2 feet by 1 feet. So what I want to do is I want to find the area of everything and then subtract out the area of these things that won't be tiled. Okay, so that's kind of the approach that I'm going to take on this problem. So to do that, I'm going to take the 16 feet that we have here, 16 by 2.5, and I'm going to multiply those together, and then I'm going to subtract out the other stuff. So I'm going to subtract 2 times 3. I'm going to subtract 2 times 1.5. I'm going to subtract out another 2 times 1.5. And finally I'm going to subtract a 2 times 1. Okay? So this is going to give me the area of that entire region. If I do that, I get 16 times 2.5 is 40, and then the other things that I'm cutting out, if I add those all up, I get 14. 6 plus these two together are going to be 6, which is 12, and then another 2 is 14. So because they're all being subtracted from the total, I'm just going to do 40 minus 14. If I do that, I get 26, and that's in terms of square feet of tiles that we need to take care of. Okay. Now, since the tiles are 1 foot by 1 foot, the area of one tile is equal to 1 square foot. Okay. Therefore, there's going to be 26 tiles needed. And to get the total cost, I'm going to take that times $2.22. So I'm going to take 26 times $2.20, and if I do that, I get $57.20. Therefore, the tile is going to cost $57.20. So the next area we'd like to take a look at is changing units of area. And we can manipulate the formula of a rectangle to derive formulas for the other figures, as I mentioned earlier in this video. In fact, all of them are going to be derived from that. So for example, if we think about a square, we know a square, the length and the width are equal to each other. So the area is equal to the length times width for a rectangle. A square is a rectangle. So if the length of one side is s, then the other side is also s, therefore the area is s squared. So a formula for finding the area of a square is just s squared. So that's why we have this formula for a square. A equals s squared. Now we can think about that as we change between different units. Now there's a lot of different units that we can use for measuring the area of a figure. We can use just the basic units, but basically any measurement that we can use for finding a length of something, we can square it to find the area of something. So for instance, if I look at this square right here, this square is 1 yard by 1 yard, therefore it's considered 1 square yard. Well, I also know that 1 yard is equal to 3 feet. So that means if it's 1 yard going across this way, it's also 3 feet going across that way. And then the same thing going down this side. If it's 1 yard on this side, it's going to be 3 feet on that side. Therefore, if you look at the number of squares that are 1 foot by 1 foot, or 1 square foot, there's actually a total of 9 of them. Therefore, 1 square yard is actually equal to 9 square feet. Alright, number 3 says we have an airport runway that is 21.5 miles long and 1/8 of a mile wide. How many square yards is the runway? And that's the key to this problem, is that I'm looking for the number of square yards. Well, the first thing I did is I just drew a picture of our runway in terms of miles. And what I want to do next is I want to convert each of those dimensions to yards first before I multiply. So if I look at 21.5 miles, well, I know that 1 mile is equal to 1,760 yards. So I'm going to take 21.5 times that number. If I do that, I get 37,840. That's how many yards we would have. And then 1/8 of a mile, I'm going to take 1,760 times 1/8, and that's going to be 220 yards. So now to find the area in terms of yards, I'm going to take those two values and multiply them together. Therefore, the area is going to be equal to 220 times 37,840. So that would be 8,324,800 square yards. So that would represent the area of the runway.